So what they did, electrophysiological recordings, my guess is they probably implanted little electrodes in their brain in those little neuron areas so they can record how those neurons fire, because neurons use electricity. Well, there's two different ways neurons communicate with each other. They communicate with electricity being generated by it's chemistry, essentially, that generates the electricity, the electrical charge, and also chemical. Chemical is from neuron to other neuron when it comes to like the neuron that's sending a message, then sends out certain chemicals to the other neuron to help that neuron develop its electrical charge, essentially, to make it sort of ramp up to send out the message some more, okay? So the chemicals are called neurotransmitters, neurochemical transmitters. Those are the little guys. That's the stuff like dopamine, okay? When you hear about like dopamine, serotonin, like that stuff, those are neurochemical transmitters between neurons, okay? And then within that neuron, it can ramp up its little electrical charge and send off that message, and it just repeats as the message goes down along your other neurons, okay? And what they're measuring is that burst. They're measuring the electrical burst. When they have electrodes put in, they're not measuring the neurochemical transmitters, they're measuring the electrical burst. That's what they're talking about there, okay? And accompanied by elevated T-type calcium currents. Okay. This is calcium currents. You're getting into what's making the electrical charge and kind of the nature of the electricity. So you have ones that either like burst firing is like, it's like a repetitive burst, you know? So you have that sort of thing. Depending on what's driving the electrical current, you can have these different ways of it developing the thing. So anyway, this is getting into the neuroscience weeds. You don't need to know all of that stuff, all right? When they inhibited this particular one, this guy, if they activated the inhibitory, which is a dimmer, the light's going down, it's turning it down, right? So the more you turn up the turn down, does that make sense at all? That was a weird way to say it. But anyway, you know what I mean? The more you darken it, the more you turn down the lights, all right? That's what the activation of inhibitory. Inhibitory is turning it down, okay? Significantly improved the behaviors that they saw in the mice.